Lynde Bradley was born on August 19, 1878, in Milwaukee. His family had once carried real weight in the city. His grandfather had served as mayor. They had lived in a fine house on the lake. But by the time Lynde was old enough to notice, the money was gone. His father drifted between ventures that went nowhere, and his mother took in boarders just to keep the household running. College was not a possibility. Lynde dropped out of high school with nothing ahead of him but whatever he could build with his own hands. He turned out to be very good at building things. He received his first patent at 16 years old. He taught himself electrical engineering through a mail-order correspondence course, and by the time he was 20, he was running a small X-ray laboratory in Milwaukee, producing diagnostic images for doctors and lawyers. But the thing that consumed him, the idea he kept coming back to, was a problem that plagued every factory and machine shop in the country. Electric motors were transforming American industry, but controlling them was brutal. The standard method used multi-step resistance grids and faceplate rheostats, crude devices that regulated motor speed by ratcheting through fixed positions. Every transition threw an arc. The contacts burned out. The speed adjustment was rough, imprecise, and violent on the machinery. Anyone who worked around heavy equipment knew the problem. The motors were getting better. The controls had not kept up. Lynde's solution was elegant. He stacked discs of carbon, a material that conducts electricity but also resists it, and compressed them mechanically. The harder you pressed the stack, the lower the resistance, and the smoother the current flowed. Company literature would later describe it as velvet smooth, and that was not marketing language. It was the difference between slamming through gears and feathering a throttle. His first application was a controller for the overhead traveling cranes that moved heavy loads across factory floors, a job that demanded precision because a jerky crane could kill someone or destroy whatever it was carrying. By August of 1901, he had a working prototype running inside the workshops of the Milwaukee Electric Railway and Light Company. But Lynde Bradley had no money. He had the invention. He did not have the capital to manufacture it, market it, or protect it. And that is where Dr. Stanton Allen entered the story. Allen was a Milwaukee orthopedic physician, born July 29, 1859, in Brooklyn, New York. He had graduated from the New York College of Physicians and Surgeons in 1880, practiced internationally, presented at the 1890 International Medical Congress in Berlin, and settled in Milwaukee in 1891. He was one of Lynde's earliest and most frequent customers at the X-ray lab, and over time, he became something closer to a surrogate father. In 1901, Allen put up $1,000 and agreed to split the proceeds from the rheostat 50-50. 2 years later, in 1903, they formalized the arrangement as the Compression Rheostat Company, setting up inside the Pfeiffer & Smith machine shop on Clinton Street, just north of Greenfield Avenue, with a rented office above a grocery store. Lynde was 24 years old. Allen was 43. In 1904, Lynde's younger brother Harry joined the operation. Harry Lynde Bradley, born January 5, 1885, was 6 years younger, and in nearly every way his brother's opposite. Lynde was quiet, solitary, most comfortable in a workshop. Harry was outgoing, assertive, a natural salesman and organizer. The division of labor happened immediately and never changed. Lynde ran the engineering. Harry ran the business. That same year, they exhibited their crane controller at the St. Louis World's Fair, and they began branding their products Allen Bradley, a calculated decision. The name, they reasoned, would outlast any manufacturing arrangement. It would become the asset. That calculation proved correct almost immediately. The company had entered into a manufacturing agreement with the American Fuse Company of Muskegon, Michigan, run by a man named Frank Jones. When Jones's company collapsed in 1911 amid embezzlement, Allen and Bradley had already pulled out of the deal, declined a $10,000 offer to sell their patents outright, and reincorporated under the Allen Bradley name. Dr. Allen was named president. Lynde became vice president and treasurer. Harry became secretary and superintendent. They were on their own. with their name on the door and their patents in hand. The early years nearly killed the company. The carbon discs in the rheostat had a heat problem. Under sustained load, the flywheels disintegrated. Orders came back. Customers lost confidence. Lynde went back to the bench and solved it, but it was close. The kind of close that does not make it into the corporate history. Dr. Allen retired to Hood River, Oregon, in 1907 for his health and became a successful orchardist. He remained president in name until his death on October 17, 1916, from a stroke suffered while picking apples in his orchard. He was 57 years old. Lynde took over as president and, out of respect for the man who had believed in him when no one else would, never removed Allen's name from the company. What followed was a period of relentless product expansion. The carbon disc rheostat was the foundation, but Allen Bradley built outward from it in every direction. Motor starters, push buttons, overload relays, contactors, circuit breakers. Each product solved a specific problem on the factory floor, and each one carried the Allen Bradley name. Allen Bradley was not alone in this market. Right across town in Milwaukee, Cutler Hammer had been manufacturing motor starters and industrial switches since the 1890s, founded by Harry Cutler and Edward Hammer just a few years before Allen Bradley existed. In Detroit, Square D had been building safety switches and circuit breakers since 1902. General Electric and Westinghouse, the giants of the electrical industry, loomed over every segment of the business. Any one of them had more capital, more engineers, and more factory capacity than Allen Bradley could match. But Allen Bradley had two advantages that none of them could easily replicate. The first was the product itself. The carbon disc technology produced a quality of motor control that was measurably smoother and more precise than what competitors offered. The second was an obsessive focus on consistency. Every component that left the Milwaukee factory had to meet the same tolerances, every time, in every batch. The company did not sell a premium product and a budget product. It sold one product, and that product worked. When the United States entered the First World War, roughly 70% of the company's orders came from the military, including control panels for Navy warships. Allen Bradley was no longer a niche manufacturer. It was an industrial supplier to the federal government, but the product that changed the company's financial trajectory had nothing to do with factories. In the early 1920s, commercial radio exploded across the United States, and every radio set needed a small, precise rheostat to control volume and tuning. Allen Bradley introduced the Bradleystat, a miniature version of their carbon disc technology, and it sold in quantities the founders had never imagined. By 1924, Bradleystat sales alone hit $1,161,380. By the middle of the decade, roughly half of the company's revenue came from the radio department. Allen Bradley was riding two booms at once, industrial and consumer, and the Greenfield Avenue factory could not keep up. In 1919, they had built a new production facility on South 2nd Street. In 1928, they added an 8-story expansion. The campus was becoming a landmark. Then, the bottom fell out. The Great Depression hit Allen Bradley the way it hit every manufacturer in the country. Orders collapsed. Revenue cratered. By 1932, the company had cut wages by 50%. The factory was running at a fraction of capacity. And here, Lynde Bradley made the decision that separated Allen Bradley from the companies that did not survive. He doubled down on research and development. While competitors froze hiring, cut research and development budgets, and waited for the economy to recover, Lynde poured what little the company had left into new products. It was a calculated bet. He told his engineers they were going to develop the company out of the Depression. One of those engineers, a man named George Mago, found the right blend of silica, resin, and carbon to produce hot-molded fixed resistors. These were small, encapsulated components that were weatherproof, precise, and extraordinarily consistent, so consistent that Allen Bradley helped standardize the resistor color code system that electricians and electronics technicians still use today. Migao built the machines to mass-produce them, and the company began turning out resistors by the millions. By 1937, employment had rebounded, and sales were approaching $4 million. Lynde Bradley's gamble had worked. In 1937, two more Allen Bradley engineers, Gustav Wilms and Albert Daw, developed the solenoid-operated motor starter. It replaced the complicated multi-part linkage and cam switches that had been the industry standard with a single moving part, a solenoid, and contacts made from cadmium-silver alloy that never needed adjustment. More importantly, the starter was designed to drop out automatically if power was lost, which meant that when electricity came back on, the motor would not restart without a deliberate command. On a factory floor full of heavy machinery, that single feature saved lives. Lynde Bradley did not live to see what the Second World War would do to his company. He died on February 8, 1942, after a brief illness, at the age of 63. He was buried at Forest Home Cemetery in Milwaukee, a quiet man who had spent his life in workshops and laboratories and had never much cared for the public side of running a business. His brother Harry, now the sole surviving founder, stepped fully into the role Lynde had never wanted. He became chairman, the company's public face, and the architect of its next chapter. During the Second World War, roughly 80% of Allen Bradley's orders were military. The hot-molded resistors went into radar sets, walkie-talkies, field radios, aircraft instruments, tanks, jeeps, ships, and submarines. Every branch of the military depended on components that had been designed and manufactured in the same Milwaukee factory where Lynde Bradley had once struggled to keep carbon discs from falling apart. The motor starters and control panels went into the factories that built the weapons, the shipyards that launched the destroyers, and the assembly lines that produced the bombers. Employment rose from around 550 during the Depression to 1,300 at peak wartime production. Total sales tripled between 1940 and 1945. Allen Bradley was now a major defense supplier, and Milwaukee was one of the most important production cities in the country. By the Second World War, women were integrated throughout the production line. After the war, the company expanded again. A 1 million square foot production addition went up in 1948. A subsidiary opened in Galt, Ontario, in 1952. The first overseas plant followed in Bletchley, England, in 1969. Product lines multiplied. Bulletin 500 contactors and relays. Ferrite magnets. The Series K across-the-line starter. The Bulletin 709 and 509 motor starters. The Bulletin 800 push buttons. These were not glamorous products. They were the components that sat inside metal enclosures on factory walls, doing the unglamorous work of starting and stopping and protecting the motors that ran everything. But electricians and maintenance workers knew them by feel. An Allen Bradley motor starter had a weight to it, a solidity that you noticed when you lifted it out of the box. The contacts seated cleanly. The overload relay tripped when it was supposed to trip and held when it was supposed to hold. The wiring diagrams were printed on the inside of the enclosure door, legible and accurate, because the company understood that the person installing the product at 2 a.m. during an emergency shutdown did not have time to hunt for a manual. The tolerances were tight. The documentation was thorough. The products lasted. In a profession where trust in your equipment is the difference between going home at the end of the shift and not going home, Allen Bradley had earned something that no amount of marketing could buy. It had earned a reputation. The kind of reputation where a journeyman electrician would specify Allen Bradley by name on a purchase order, not because someone told him to, but because he had opened enough panels over enough years to know what held up and what did not. On October 31, 1962, Harry Bradley, now 77 years old, threw the switch that lit the Allen Bradley clock tower for the first time. It rose from the roof of the Research and Office Addition, 280 feet from the street, with 4 octagonal clock faces, each 40 feet and 3.5 inches in diameter. The hour hand was nearly 16 feet long and weighed 490 pounds. The minute hand stretched 20 feet and weighed 550 pounds. The Guinness Book of World Records certified it as the largest 4-faced clock in the world, a title it held for nearly 50 years until the Makkah Royal Clock Tower in Saudi Arabia surpassed it in 2010. The translucent faces were made by Super Sky Products of Mequon, Wisconsin. The clockworks were built by Lynde Bradley's own engineers. The chimes were deliberately omitted. The neighborhood on Milwaukee's south side, heavily Polish and working class, gave the tower a nickname that stuck. They called it the Polish Moon. Harry Bradley had intended it as a gift to the community, a village clock for the people who lived and worked around the factory. But Harry Bradley was also a man of deep and increasingly rigid political convictions. He was a founding member of the John Birch Society, alongside Fred Koch, the father of Charles and David Koch. He supported anti-communist causes with company money. He backed Robert Taft in 1952 and Barry Goldwater in 1964. He believed that social spending in America was part of a deliberate plot to weaken the country. He died on July 23, 1965, at the age of 80, and was buried beside his brother at Forest Home Cemetery. His daughter, Jane Bradley Pettit, became one of Milwaukee's most prominent philanthropists. The company Harry left behind was enormous. More than 7,000 employees worked at the Milwaukee campus. Allen Bradley dominated the North American market for industrial motor controls. The product line stretched from tiny resistors to full motor control centers. In 1968, General Motors issued a challenge to the entire industrial controls industry. GM wanted a programmable replacement for the massive hardwired relay panels that controlled its assembly lines. These panels were walls of electromechanical relays, hundreds of them wired together in specific sequences to control each step of a production process. Every time a model year changed, the relay panels had to be physically rewired. Electricians spent weeks pulling wires, tracing circuits, and testing connections. It was expensive, slow, and error-prone. And for a company launching new car models every year, it was a bottleneck that cost millions in downtime. GM did not want a better relay panel. It wanted something that could be reprogrammed without pulling a single wire. Several companies responded. Allen Bradley purchased a small firm called Information Instruments in 1969 and began development. The early attempts missed the mark. One prototype, the PMC, was physically too large for a production environment. Another was too slow to process the logic fast enough for real-time factory control. But by 1971, 2 Allen Bradley engineers, Odo Joseph Struger, an Austrian-born engineer who would later be called the father of the programmable logic controller, and his colleague Ernst Dummermuth, developed the Bulletin 1774 PLC. It was a solid-state device that could replace an entire relay panel, and it could be reprogrammed by a technician using ladder logic, a programming language deliberately designed to look like the electrical schematics that every factory electrician already knew how to read. The genius of the PLC was not just that it worked. It was that the people who already maintained the factory could learn to use it without going back to school. It was Allen Bradley that coined the term programmable logic controller, a name that became the industry standard after PC was claimed by the personal computer. PLC did not just replace relay panels. It transformed factory automation. It made production lines reprogrammable, flexible, upgradable. Allen Bradley followed the 1774 with the Data Highway Network in 1979 and the PLC-2, PLC-3, PLC-5, and SLC 500 families that defined industrial control for the next 3 decades. If the motor starter had made Allen Bradley the name on the factory floor, the PLC made it the brain. By the early 1980s, Allen Bradley was approaching $1 billion in annual sales. It was the undisputed leader in North American industrial automation. It was still privately held, still family-controlled, still headquartered in Milwaukee. But the world was changing. Siemens, Omron, and other foreign competitors were investing heavily in automation. Expanding globally to meet them would require capital that a closely held family company could not easily raise without losing control. The Bradley family, now spread across 7 interlocking trusts, faced a decision. On January 17, 1985, Rockwell International, the Pittsburgh-based aerospace and defense conglomerate behind the Space Shuttle Orbiter and the B-1 bomber, announced an agreement to buy Allen Bradley for $1.651 billion in cash. It was the largest company acquisition in Wisconsin history. Allen Bradley President and Chief Operating Officer J. Tracy O'Rourke represented the company in the negotiations. The deal closed just 34 days later, on February 20th, 1985. Rockwell deposited the cash directly into the 7 family trusts at Mellon Bank in Pittsburgh. A company that had been privately held for 82 years changed hands in a single transaction, and the people who worked inside it learned about it from the news. For Rockwell, it was a strategic move into high-growth factory automation, a market where it expected to compete with General Electric, IBM, and Siemens. For the Bradley family, it was the end of a dynasty. The decision to sell was driven in part by the sheer cost of competing globally. Siemens, Omron, and other foreign automation firms were investing hundreds of millions in research and development and international distribution. Allen Bradley could not match that spending without either taking on massive debt or opening the company to outside investors, either of which would dilute the family's control. The trusts chose the exit. The sale did 2 things that would echo for decades. First, it transformed the Lynde and Harry Bradley Foundation. The foundation had held roughly 20% of the company's stock. Overnight, its assets leapt from $14 million to approximately $290 million. What had been a modest family philanthropy became one of the largest and most politically influential conservative foundations in the United States. It funded the Heritage Foundation, the American Legislative Exchange Council, the Federalist Society, and dozens of other organizations. Internal documents leaked in 2016 revealed a deliberate long-term strategy to shift political influence to the state level, targeting legislatures in Wisconsin, North Carolina, Colorado, and other swing states. Harry Bradley's John Birch Society politics, filtered through the proceeds of the Rockwell sale, became a permanent force in American conservatism. The money that once paid Milwaukee factory workers now funded a national political infrastructure. Second, the sale began the slow death of Allen Bradley as a Milwaukee employer. Allen Bradley had already started shifting some production to the American South and to rural Wisconsin in the 1970s. But under Rockwell, the pace accelerated sharply. Production moved to Mexico, China, and the Dominican Republic. The machines that had been built by Milwaukee hands for 80 years were now being assembled in plants where labor cost a fraction of what it cost in Wisconsin. The union that had represented Allen Bradley's factory workers since the 1930s, United Electrical Radio and Machine Workers Local 1111, watched its membership collapse. In 1980, the local had 5,500 members. By 2006, it had 550. Local 1111 was not an ordinary union. It had a 73-year history of progressive labor activism, coalition building with civil rights organizations, and aggressive shop floor advocacy. It had walked picket lines at Allen Bradley as far back as 1939, a 3-month strike that went all the way to the United States Supreme Court on the question of whether the state had jurisdiction to restrain the picketing. It had organized drives across Milwaukee. It was the institutional memory of the Allen Bradley workforce, and Rockwell was hollowing it out one retirement at a time. Rockwell kept the Allen Bradley name on the products and moved its own corporate headquarters into the Milwaukee building in 1999. In 2001, the automation business was spun off as Rockwell Automation, the legal successor, trading on the New York Stock Exchange under the ticker ROK. The defense side became Rockwell Collins. The Allen Bradley brand survived. The Allen Bradley jobs did not. The union fought it every step of the way. Local 1111 had been a progressive force in Milwaukee labor for 73 years. It had launched organizing drives, built coalitions with civil rights groups, and battled both Allen Bradley and Rockwell over wages, conditions, and the right to keep production in Milwaukee. Its leadership understood what was happening. Carl Rosen, the union's president, said it plainly. Rockwell made a decision a dozen years ago that they were going to shut down production in Milwaukee. But the local managed something that most unions in similar situations did not. It negotiated so that almost all the job losses occurred through retirement. Workers left with full pensions and healthcare benefits instead of being laid off into a market that had no use for them. It was a controlled retreat, not a rout. On July 31, 2009, at midnight, the last contract expired. The gigantic clocks on the tower above the factory kept running, but local 1111, 73 years old, was finished. Its 7,000 members were gone. The factory floor where they had built switches, relays, timers, starters, and motor controls for 3 generations was being cleared out. The production had moved overseas. Today, Rockwell Automation still operates from the building beneath the clock tower. It is a global company with roughly 28,000 employees and more than $8 billion in annual revenue. The Allen Bradley name still appears on motor starters, push buttons, and variable frequency drives in factories around the world. Electricians still reach for it. Maintenance workers still trust it. The name still carries weight on every job site and in every electrical supply house in North America, not because of a marketing campaign, but because 3 generations of tradespeople put their hands on the product and found that it worked. If stories like this one are why you're here, subscribe to Trade Archive. There is more to come.